Today's notes are going to be on 2.3 product and quotient rules and higher order derivatives. So we've already done rules 1 through 6. We are going to start off with rule 7 now. So rule 7 is the product rule. Now in the product rule, we are going to take the derivative of function f of x and multiply that to function g of x. And the way that we do this is you're going to keep the first function the same, which is going to be f of x. You are going to multiply it by the derivative of the second function, which is g prime of x. Then we are going to add the second function. So you're going to leave the second function alone, and you're going to multiply that to the derivative of the first function. That right there is the product rule. So basically right here, that's just going to be the first function by itself. This right here is going to be the derivative of the second function, and you are adding. Then you're going to take the second function and you are going to multiply it by the derivative of the first function. Another notation that you might see is they might use function f of x as a u. So you might see it like this. Function u times function v. Basically, you leave the first one alone. So you leave that as a u. Then you take the derivative of v. So that's going to be v prime. Plus, then you keep the second one the same. And then you take the derivative of the first. That's another way you guys can see it. So for the first example, I have f of x equals, the first function is going to be a 3x to the 4 minus 2x. And the second function is going to be 5x minus 1. So right here, this is going to be your f of x. This is going to be your g of x. Or this is your u, this is your v. This is just the regular function. Now I'm going to go ahead and I'm going to take the derivative. And because I'm taking the derivative, don't forget the little prime symbol right here. That's telling my reader that I'm taking the derivative. You are going to keep the first function the same. So I'm going to keep it the same. So that's going to be a 3x to the 4 minus 2x. And now I have to take the derivative of the second function. The derivative of 5x minus 1 is just the number 5. Plus, I'm now going to keep the second function the same, which is a 5x minus 1. And I'm going to take the derivative of the first function. Now, the derivative of the first function, make sure you are putting in parentheses, because right here, when I bring the 4 down, I get a 12x decrease the power. And then the derivative of 2x is just 2. I'm now going to simplify this. So I'm going to go ahead and multiply the 5 here, and then I'm going to distribute this out. So 5 times 3x to the 4th power is going to be 15x to the 4th minus 10x plus, that's going to be a 60x to the 4 minus 10x minus 12x to the 3rd plus 2. I'm now going to combine like terms. My highest power is x to the 4th. That's going to give me a 75x to the 4th. My next power is going to be an x cube. So then that's minus 12x cube. I don't have any x squares. And then I have this negative 10x, which gives me negative 20x. And then I have this constant of 2. Now, yes, you could have just distributed all of this out and then taken the derivative, but I just wanted to show you guys the product rule. Rule number 8 is now going to be the quotient rule. Quotient means to divide. So the quotient rule, once again, we're going to have f of x and we are dividing it by g of x. Now I'm going to write out the formula, but I also have a little saying to help out to memorize this one right here. On this one, you keep the bottom the same and you take the derivative of the top. And instead of adding here, you're actually going to be subtracting. Then you keep the top the same and then take the derivative of the bottom. And then you're going to divide all of that by the denominator square. Now here, g of x cannot equal 0 because if you divide by 0, it is undefined. Now let's say they didn't use f of x and g of x, they use u and v. Now this is the little saying. It is low d high subtract high d low all over the bottom square. Now, when I say d high, that's the derivative of the high term. When I say low, you just keep the low term there, the same. So low is v. So that's just going to be v. D high means the derivative of the upper one, which is u. So the derivative of u is going to be a u prime. Subtract high is the u, times d low is the derivative of the bottom, which is v prime. All over the bottom is v square. That's the same here. Look, the low is the g of x. D high is the derivative of the upper. That's what gives me the f prime. Minus high, you just write f of x because that's the high term, times d low is the derivative of the lower term, which is the g of x. So let's go ahead and apply that. So we have f of x equals 3x squared minus 2 over x plus 1. So this is going to be your high. The high is the upper one, and the x plus 1 is the lower one. So the 3x squared minus 2 is the high, x plus 1 is the low. And whenever it says a d, then that means you're taking the derivative of that one. You're taking the derivative of that one. So the derivative of f of x is going to be f prime of x. So low is going to be x plus 1. D high, you're going to take the derivative of the numerator. And the derivative of the numerator is just 6x. Subtract. Now you're going to keep the high the same. The high is going to be the 3x squared minus 2. And then d low is the derivative of the bottom. The derivative of x plus 1 is just 1. And then you're going to divide that by the bottom square. The bottom is going to be x plus 1 squared. In the numerator, I'm going to go ahead and I'm going to simplify that. So 6x times x is going to be 6x squared. 6x times 1 is going to be a 6x. Now right here, it says minus. When you're multiplying by 1, it doesn't really change anything. So I'm just going to distribute the negative inside. So that's going to be a negative 3x squared and a positive 2. Because a negative times a negative makes that a positive 2. In the numerator, I'm going to go ahead and I'm going to combine like terms. 6x squared minus 3x squared. That's going to give me a 3x squared. Nothing goes with the 6x and nothing goes with the 2. I'm going to go ahead and stop there because you can't actually simplify the numerator. Sometimes you'll be able to factor the numerator and it might cancel out with one of the denominators, but that's not the case here. So that's how you do the product rule. And look, this right here is your, because remember, that's your u, that's your v. That's your u, v prime, minus, that's your u, that's your v because it's a low. Here's u, here's v. Here is low d high, subtract high d low. That's what those terms are. To make this easier, we are always going to simplify in algebra, and then we're going to rewrite before choosing a rule and differentiate, meaning taking the derivative. For an example one, we're going to use the constant multiple rule. So here I'm going to put whatever my function is. I'm going to rewrite it. Then I'm going to differentiate, so take the derivative. And lastly, I'm going to simplify. So for the first one, if we have y equals x squared plus 3x all divided by 6. Now, when I say to rewrite it, that 6 actually is a denominator on both terms. Now, there's a 1 here, you just don't see it. So when I rewrite this, this is actually y equals 1 over 6x squared plus, then I have 3x over 6. Well, 3 over 6 is equal to 1/2 x. These are still the same. I did not take the derivative yet. All I did was I put the 6 underneath both terms in the numerator. Now, when I differentiate, I need to take the derivative. So the derivative of y is going to be a y prime. And then right here, you're going to do the bring down the 2. So that's 2 times 1, 6, which is 2, 6. 2, 6 reduces to 1/3 x. And then I decrease the power. So the power is 1 plus right here, the derivative of 1/2 x is just going to be 1/2. Now, this answer is technically correct. On a multiple choice test, it might show up like that, or it might not show up like that. They might make you get common denominators. If you have to get common denominators, the denominator would be the number 6. So how do I get a 6 here? By multiplying that by 2 and that by 2. So that's going to be a 2x. And to get a 6 here, I have to multiply this by 3 and 3. So that gives me a 3. Your answer might also be written like this. These are the same thing. On problems like this is especially why we want to simplify first and then take the derivative. Because right now, the way it's written, you have a fraction. So you're doing the quotient rule here and then the quotient rule here separately. We don't want to do that. So what I'm going to do here first is let me simplify each term. Now there is a 1 here, you just don't see it. When you have a fraction, you need to take the top power, which is 3/2, and subtract it by 1. 3/2 subtracted by 1 is positive 1/2. So this is going to be a 3x to the positive 1/2. Right here, there's a 1 here, you just don't see it. We're going to be left with the number 2, because that's a constant. 1 minus 1/3 is going to give me 2/3. Now I can easily take the derivative, take the derivative. The derivative of y is y prime. Right here, I'm going to go ahead and bring the 1/2 down. So if I bring the 1/2 down, I am left with 3 over 2x. And then I'm going to decrease my power. So 1/2 minus 1 is going to be a negative 1/2. Plus, when I bring the 2/3 down, 2/3 times 2 is going to give me a 4/3. And then when I decrease the power, 2/3 minus 1 is negative 1/3. Now, when I say simplify, what I mean by simplify is I don't want these negative exponents. Negative exponent just means it's a denominator. It just means it's a denominator. So right here, this x to the negative 1/2 is actually on the bottom with 2. So that's going to be a 3 over 2x to the positive 1/2 plus I have a 4 on the numerator, and then that x to the negative third is now going to be on the bottom with the number 3. And instead of a negative power, it's going to be a positive power. I'm going to go ahead and leave it like that. I'm not sure if it would make you get common denominators, but you could leave it like that for now. All right, let's go ahead and let's do some more examples. We're going to find the derivative of the algebraic function. And then we're also going to be finding the derivative of the trig ones as well. Trig and E ones. On this one, I have two functions. This is going to be U. This is going to be V. I have two functions. I'm going to do the product rule here. So the derivative of F is going to be F prime of X. Product rule. You keep the first the same. You take the derivative of the second one. The derivative of the second one is just going to be a negative 3. Plus you keep the second the same. And then you take the derivative of the first one. The derivative of the first one is just the number 1. So you keep the first one the same, take the derivative of the second, plus you keep the second the same, and you take the derivative of the first one. Negative 3 times x is just going to be a negative 3x. Right here, I'm going to distribute the 1, so I'm just left with a positive 2 minus 3x. And make sure you're paying attention to that symbol between there. I'm now just going to combine like terms. Negative 3x minus 3x is negative 6x. So your final answer, the derivative, is going to be a negative 6x plus 2. On B, we now have a quotient rule. Okay, this is the quotient rule. Whenever I refer to the high, this is the high. This is the low. You are now going to be using this formula right here, the low D high subtract high D low. Low D high subtract high D low. So the derivative of y is going to be y prime. Low, keep low the same. D high is the derivative of the numerator. The derivative of the numerator, the derivative of 4x squared is going to be 8x. And the derivative of 7x is 7. And then derivative of 1 is 0. Subtract high. So now keep the high the same. And D low, the derivative of the bottom is just going to be the number 1. All over the bottom square. I'm going to go ahead and multiply this out right here. So if I do this, that's going to be 8x squared. That's going to be minus 7x minus 8x. And then negative 1 times 7 is positive 7. And then right here, the 1, when I distribute it, it's not going to change anything. And the reason why I left it in parentheses is because that negative is going to need to be distributed inside. Don't lose your denominator. So the first one right here, I notice that these are like terms. So I'm going to put those together. So I'm left with 8x squared minus 15x plus 7. And then this negative has to be distributed to all the terms. So that's going to be a negative 4x squared, a positive 7x, and a negative 1. Lastly, I'm going to go ahead and I'm going to combine like terms in the numerator. 8x squared minus 4x squared is going to be 4x squared. Negative 15x plus 7 is going to be negative 8x. And then 7 minus 1 is going to be a positive 6. Now that answer, if it's a free response, is okay, but that's probably not going to show up because in the numerator, I noticed that they are all even numbers. So 2 actually goes into all of them. So I like this answer better, but both of these are correct. All right. C, we have f of x equals 4 square root of x times square root of x plus 2. On this one right here, we do have two functions, okay? We do have two functions. So we can do the quotient rule, the product rule, or, well, yeah, we have to do the product rule. Let's just go ahead and do the product rule. I'm going to rewrite this though. This is actually x to the 1/4 power. And that's x to the 1/2 power plus 2. We're going to do the product rule. This is going to be my u. This is going to be my v. So all of this is the u. All of this is the v. The derivative of f is going to be f prime. Keep the first one the same. Keep the first one the same. When you take the derivative of the second one, you bring the 1/2 down and you decrease the power. Now, the derivative of 2 is 0. So I kept the first one the same and I took the derivative of the second. Now I have to keep the second the same and take the derivative of the first. So the derivative of the first, I'm going to bring the 1/4 down and then decrease the power by 1, which gives me negative 3/4. So I kept the last one the same, and I times it by the derivative of the first. I know it looks ugly. Sorry. Now, these two are being multiplied. Keep in mind, when you are multiplying fractions, you are technically adding them up. So right here, I have the 1/2. When I add up the powers, 1/4 minus 1/2 is going to give me a negative 1/4. It's going to give me a negative 1/4. Now I'm going to go ahead and I'm going to add. Now right here, when you distribute this 1/4, you're going to be left with 1/4 times 1, which is 1/4. And then here, when you add up these powers, you have 1/2 minus 3/4. That's going to give you a negative 1/4. And right here, when I multiply these, 2 times 1/4 is 1/2. And then don't forget the negative 3/4 right here. Now, these are like terms because they both have powers of negative 1/4. So you can go ahead and you can add the coefficients up. 1/2 plus 1/4 is going to be 3/4. Now, that answer is correct, but more than likely, they're going to make the fraction go to the bottom because that's a negative exponent. So the correct answer here would be 3 in the numerator, 4x to the 1/4 plus 1 in the numerator, 2x to the 3/4. Let's go ahead and do another example. We're going to do a quotient. So this one is going to be a lot of fun, I promise. We have y equals 3 minus 1 over x, all divided by x plus 5.
Now, I have a fraction over a fraction, okay? So I'm going to purposely solve this incorrectly. I'm going to tell you right now. I'm going to purposely solve this where it's going to be like, ugh, and then I'm going to teach you a way to make it easier. So right now, you might want to automatically be like, okay, I'm going to move that to the numerator. So that's going to be x to the negative 1 power. So if you rewrite this, you could rewrite this as 3 minus x to the negative 1 over x plus 5. Okay, it doesn't look that bad right now. But let's go ahead and now let's do the quotient rule. This is going to be your high. This is going to be your low. Once again, we are using this low d high, subtract high d low. So right here, the derivative of y is y prime. It's going to be low, keep the low the same. Now, when you take the derivative of the high, the derivative of 3 is 0. When I bring down negative 1, and negative makes that a positive, and when I decrease that power, that's going to be a power of negative 2. Subtract high, and then d low, the derivative of the bottom is 1. Okay, it still doesn't look bad. All over the bottom square. If I try to simplify this right here, that's actually technically a denominator of x plus 5. So this would be x plus 5 over x to the positive 2 power minus, and then right here, that's going to be 3 minus 1 over x, because that negative power means it's a denominator. The 1 doesn't really play a role here because when you multiply, you get the same. Okay, this just looks like a hot mess, okay? So I want you to stop right here, and we need to rethink the problem. Okay, we're going to stop and rethink the problem. Let's go back to the very, very beginning, where we had y equals 3 minus 1 over x plus 5. From the very beginning, I could have canceled that x out. And how do we do that? We have to multiply. We are going to multiply to cancel the denominator that's up on the top. That is in the numerator. So I'm going to multiply the entire top by x, and whatever I do to the top, I do to the bottom. I am multiplying by a form of 1. X divided by x equals 1. So I'm not changing the value of the problem. So if I do that, x times 3 is going to be 3x. But then right here, when I multiply x times 1 over x, that's just the number 1. In the denominator, x times x is going to be x squared, and x times 5 is going to be a 5x. Now, this looks a lot better than all of this. And now, once again, this is going to be your high, and this is going to be your low. So now when we take the derivative of y is going to be y prime, and it's going to go low, d high is just the derivative of the top one, which is 3, subtract high, and d low here is going to be a 2x plus 5. And all of that is being divided by the denominator square. Now let's go ahead and simplify the numerator. I'm going to simplify this part and then simplify this part, and then I'll distribute the negative after. So right here, I have 3x squared plus 15x. And then here I have 3x times 2x, which is 6x squared. 3x times 5 is 15x. Negative 1 times 2 is negative 2x. Negative 1 times 5 is negative 5. Now, keep in mind, these are like terms. That's technically just 13x. Now I'm going to go ahead and I'm going to distribute the negative to all the terms on the right side. So here I have a 3x squared plus 15x.
That's going to give me a negative 6x squared. Now remember, that's 13x, so a negative times positive 13x is negative 13x minus 5. I'm going to go ahead and combine like terms in the numerator. 3x squared minus 6x squared is going to be negative 3x squared. 15 minus 13 is positive 2x. And then the only constant is, oh, actually, I messed up. Negative makes that a positive 5. Positive 5.
I'm going to go ahead and just leave my answer like that. All right, let's do an example with a trig now. I'm going to actually show you guys this two different ways, okay? One way you could do this is you can actually put both of these under sine x.
So f of x is equal to 1 divided by sine x minus cosine x divided by sine x.
Now, 1 over sine, that's technically cosecant x. And cosine x over sine x is cotangent x. I have not wrote derivative because all I'm doing is simplifying. I have not taken the derivative yet. Now I can go ahead and take the derivative. So the derivative of f of x
is going to be f prime of x.
Now I'm taking the derivative. The derivative of cosecant, you guys have to memorize this,
is negative cosecant x cotangent x.
Subtract the derivative of cotangent x
is negative cosecant squared x.
Don't forget, this is cosecant x, cotangent x. Don't tell me cosecant, cotangent x. No, cosecant needs its own argument. Right here, a negative times a negative makes that a positive. Now, technically, that is correct, but I do notice that both of these have a cosecant. So I'm actually going to factor out the cosecant. And usually we never leave a negative out in the front. So inside a factor, so we have to factor it out. So I'm going to factor out negative cosecant x. So if I factor out the negative cosecant x here, I'm left with cotangent x. And if I factor out a negative here, I need another negative because a negative makes that the positive cosecant square.
And I only took one of the cosecants out, so I still need one left.
More than likely, this is going to be the answer that shows up on a multiple choice test. Now, let's say you didn't do it like that and you did it like this. And you went ahead and you just did the quotient rule because, once again, you see the division. That's going to be your high.
And that's going to be your low.
Low. Now, D high, the derivative of 1 is 0. The derivative of negative cosine is positive sine. Subtract high. And now D low, the derivative of sine is going to be cosine x. All over the denominator square. Sine x times sine x is sine squared x.
Now right here, I'm going to distribute, so that's going to be a cosine x. That's going to be a negative cosine squared x.
I'm going to go ahead and I need to distribute this negative inside the parentheses.
So it's going to be a negative cosine x and a positive cosine squared x.
I noticed right off the bat that this is an identity. That is an identity. Sine squared x plus cosine squared x, that equals 1. So that simplifies to the number 1. And this answer is also correct. I can actually manipulate this one to make it look like this, and I can manipulate this one to make it look like that. Okay? Right here. Do not let these thetas throw you off. This is theta plus 1 times cosine of theta. Theta is just it's just like an x. If you want, you could say x plus 1 cosine x. And then at the end, just go back and plug your theta back in as x. Okay, I'm just going to leave theta here, but theta is just like x. So the derivative of f is going to be f prime of theta. This is the product rule. Okay, theta. So you're going to keep the first function the same. So that's going to be a theta plus 1. Now, when you take the derivative cosine of the argument is going to be negative sine of the argument. Plus, keep the second the same, which is cosine theta. And now you're going to take the derivative of the first one. Now remember, if that was x plus 1, the derivative of x plus 1 was just 1, right? So the derivative of theta is just going to be the number 1. And then the derivative of 1 is going to be 0. Now I'm going to go ahead and I'm just going to distribute the negative sine theta. So my final answer here is going to be negative theta sine theta. Do not multiply those two thetas. That's an argument. That's a constant. You can't have the theta jump inside the trig. Minus sine theta plus cosine theta. If the theta is throwing you off, just plug in x. So that's x plus 1 times cosine x. And then when you're done, you're going to replace all the x's with the thetas. Okay. Last part. Higher order derivatives. So you can take the derivative more than one time. So for the first derivative, we usually write that as y prime. You can also see it as f prime of x or dy over dx. This is all means first derivative. You can also see like this, d dx of the function and dx of y. Those are all ways to write first derivative. Second derivative. Instead of saying y prime, it's going to be y double prime. And from that, you can guess. Instead of saying f prime of x, it's going to be f double prime of x. dy over dx is the derivative square of y over dx square. This is going to be d square over dx square. This is going to be dx square of y. If you are finding the third derivative, and will we be doing that? Yes, we will. Once again, instead of y double prime for second derivative, this is going to be y triple prime. F triple prime of x. D cube y over dx cube. D cube over dx cube of f of x. Dx to the third of y. You could continue going on and on and on. I could ask you to find the 12th derivative. So that leads us to the nth derivative. That's any number derivative. The way this is written is you're going to write y, and notice how third had 3 prime symbols. Right here, it's just going to have a power of n. Same here, it's going to be f to the n, because that's going to be your nth term. This is going to be dny over dx to the n power.
d to the n power over dx to the n power, dx to the n power of y.
When do we use this? We use it a lot when we do position to velocity to acceleration. Now, x of t, also known as s of t, that is known as the position function. Function. Now, if you take the derivative of the position, that is going to give me the velocity function. And if you take the derivative of the velocity function, that's going to give you the acceleration. Which this happens to be the second derivative of the position. And that concludes our notes.